Good morning. Good morning. All fine? Good morning. Yes, all fine. Brightness, I think more. Yes. Good morning. All fine? All fine. Okay. Yes. Mm. Yes, all fine. Okay, so from today onwards, we'll be having our main syllabus. Last week, yes, good morning. So last week, basic mathematics was there. Mm. Yes. Yes, good morning, good morning, good morning. Ah, okay. So now we are going to start our thermal physics basically. Okay, thermal physics, like we have modern physics. Okay, so today we are having your thermal physics, and before NTA thermal physics was having that weightage was more for the thermal physics. It's too bright actually. That setting I wish. Yes. Now I think okay. So before NTA, this chapter was having good weightage. It was around 5 questions were coming from thermal physics, but after the NTA, they have changed this thing. Sometimes 2, sometimes 3 questions are coming out of this thing. But anytime they can change the pattern, so we can expect any year we can expect again. Okay, again we can expect 4 5 questions from here, so we cannot ignore. Okay, like modern is also important, thermal is okay, modern is quite important in our 12th class, and this one in our 11th. Okay, and this one we are going to use also, like uses will be there in your sometimes we think that there is no use of physics, so a lot of uses we'll see. Okay, this first, so in the thermal physics 6 subtopics are there. First one we are having here, that is your thermometry. Then we are having here thermal expansion. Then the second one. Third one we are having your calorimetry. Fourth one is mode of heat transfer. As per NCERT, these 4 subtopics are given in single chapter. Okay, all 4 are given in single chapter. That is your thermal properties. One chapter is there. Then we can say, then is we have here KTG, means kinetic theory of gases, and then we have thermodynamics. Okay. So out of these 2, if I say that from these 2, okay, KTG and thermodynamics, regularly they are asking the questions. Okay, regularly they are asking here, and out of these, okay, they can ask 1 or 2 questions depending on them. So these things we have to do. First one we are going to write thermometry. So you can write the heading thermometry. Now if I say thermometry means, you can write this heading thermometry. We can say thermometry means, metry means basically measurement, and thermo means basically temperature. So we are having here measurement of temperature, nothing else. So in this chapter we are having measurement of temperature. Now if I say what is the temperature actually, okay, we are going to measure for the measurement of temperature in this chapter, means thermometer and all the things we'll see today. Okay, how to make. And today you can you will be able to make your own thermometer also. So we can say here in this one, temperature if I say, so you can say what is the temperature basically. This is nothing but the degree of your hotness or coldness. So degree of hotness and coldness is known as temperature. Okay, so these are very basic definitions that I said here, that what are the temperature, what we are going to do in this chapter. Yes, So can we start now? Can we start this chapter now? Because today we have to finish this chapter, okay? Thermometry is the chapter of one lecture. We need to finish. Already we are late also. Because last class, okay, you were having so much chemistry. Yes. And then in the meanwhile, some problem came, technical problem. So class was almost, we are half an hour late, half an hour left. Okay, so now we can say if you want to measure anything for the, like if I say I want to find length of this one, then you can say, sir, you need basically one scale. We require one scale for the measurement of length. Okay, we can have centimeter scale, we can have your inch. Okay, so basically for the centimeter scale, you can say, sir, one point we have lower, that we write as 0. Here we write as okay, 15. We can use that scale. If I say I want to find the weight of this one, then you can say, sir, you need okay, you can take weighing scale. Okay, now can I use that scale for the measurement of weight that we are using that scale for our weight? The same scale can be used for weight of this pen, because every scale is having some limit, like lower limit to upper limit, that in this range we can use. Like if I say centimeter scale is there, using centimeter scale I cannot find distance from here to your okay, it will be very tough for us, because that is having only 0 to 15, one limit is there. So like we having a weighing scale, they'll be having a, like it can read from 1 kg to 10 kg. So up to 10 kg we can use. Some scales, if you're going to purchase jewelry, they are very precise. They can take even okay, 0.01 gram also effectively. So they are precise from that level too. So one limit is there, minimum and maximum is lower and upper. So for any scale we need to decide that, okay, between these two values scale will be your this scale will work between these two values. So if I say I want to make my own scale, I want to make my thermometer, so you can say to make the thermometer what I need. To make thermometer basically, okay, you can say, sir, you need one long tube, and here we can put just this bulb, okay, and then in this bulb you need to fill something. What I can fill? Yes, your suggestions. What I can fill? Yes. So I have taken two type of bulb. One bulb is spherical, one bulb is cylindrical. Yes, mercury will fill. Okay. We can fill any of the liquid. There is no problem. Okay, you are saying the mercury because you have seen all the time mercury. But yes, we can use only thing that material must be having some properties. Okay, so we'll write what are those properties. But I'm asking right now that one I have taken a cylindrical, one is the okay, your spherical. Which one will be more effective? Which one is more effective first of all? If I want to make the thermometer, yes, your spherical one or cylindrical one? Which one will be okay? Just shape I'm changing in the thermometer. This is the okay first one. This is the second one. Which one is more okay? Cylindrical is of course used because sphere will be having lesser area. So whenever you are taking the readings, then less area will be in contact. Like whenever we are taking the reading, then we keep here, okay? So less area will be in contact in case of spherical. So we will prefer cylindrical. That's why most of the thermometer that you have seen, clinical thermometer that you have seen, you have okay used also, that is actually that okay, bulb is always cylindrical. This is the first question that you need to remember, that bulb we prefer is the cylindrical. Okay, we'll write this thing. Now, whatever the material we need to fill here, then first important property for that material is that material must be having expansion should be more. Okay, its expansion should be more, because suppose you are taking that material and you keep on heating and that material not expanding, of course we cannot have proper readings. So we need to have that material which is having better expansion, number one. And number two, basically specific heat. What do you say? Specific heat should be more or less? Specific heat should be more or less? Like water, if I say water specific heat is, water is having your high value of specific heat. High value of specific heat, when we will have this specific heat chapter, at that time I will tell, it will be cooled slowly and heated slowly. Means if you take the water here in place of this one, then what will happen? When you will keep in contact, then slowly it will be heated. And then okay, it will take so much time for the readings. It will never be accurate. Okay, if specific heat is low, then it will be heated fast. cooled also fast. Suppose you want to take the second reading, you can take easily, okay? So these 2 points you have to remember. Other than that, so many properties are there. We are not going to write everything. We will write the technical points. Number 1, specific heat should be less, and number 2 is basically your, okay, expansion should be more. So you can write first point here in this one, okay, that spherical means cylindrical bulb is cylindrical cylindrical bulb is preferred over spherical. Cylindrical is preferred over spherical. Okay, write always key points. Cylindrical bulb preferred over spherical. In bracket you will write the reason. What is the reason for this? Why we prefer? What is the reason? What is the reason? What will write in the bracket? What is the reason? Why we prefer? In the bracket you can write sphere has less area. Sphere has least area. Okay, least area. So if least area, then only least area will be in contact, and here more area will be in contact. So readings will be somewhat quick. Area of contact in case of sphere will be less. Okay, least area. Least area means less area for contact will be there. Okay, clear? First point. Then you will write here properties of material. Okay, properties of material, whatever, okay, used in thermometer. So properties of material, whatever we have to use, you can write number 1. Okay, whatever property we are going to use, you will write here number 1. First you will write more expansion, because more expansion is clearly visible to you. Just yes, it's how to expand quickly, so expansion should be more expansion. Okay, in thermal expansion chapter I will tell how many times of, okay, what the expansion of mercury with respect to water, but as of now you will remember it should be having more expansion. Okay, number 2 low specific heat. Number 3 you will tell, okay, like this. 2 important, we can write after this so many. It should stick with the walls. It should be sticky or non-sticky. What do you say? Whatever you will say, will write sticky or non-sticky. Non-sticky. Okay, in surface tension you will get to know about the contact angle. Okay, that contact angle is more, contact angle is less, then what happens? So their question can be asked with respect to why mercury is used, because it have more acute contact angle, obtuse contact angle. But as of now we'll only write non-sticky. Okay, so here you can write number 3 non-sticky. Okay, yes. And then now other reason we are not writing that it is shiny. Okay, it is this, so okay, not interested. Non-sticky. Okay, because these 3 will use expansion in this one, and non-sticky with respect to contact angle in the surface tension will have. Okay, so question related to the contact angle can be asked. So non-sticky. Okay, why it is non-sticky? Because of the contact angle region is there. Okay, so now what we'll do, basically you have taken here that this is the there, then we have taken this cylindrical bulb. In this one you will fill the mercury. Then you need to take 2 reference point. So first we'll keep this bulb at the 0 degree Celsius. When you will keep this one at the 0 degree Celsius, okay, 0 degree Celsius, water, we can see your ice water. Okay, so you will find that suppose mercury is up to this one. So here you will write 0 degree Celsius. Then this same thermometer you will put, okay, you will keep in the 100 degrees Celsius, means boiling water, and then you'll find mercury will expand, and mercury will be suppose coming up to this point. So here we'll write 100 degrees Celsius, and then you will divide this one into 100 equal parts. Okay, 100 equal parts, and here each part will be indicating 1 degree Celsius. Suppose if I want to find my temperature, then I will keep here, and suppose this is going to the mark of 38, it means my temperature is 38. This way we can make our thermometer. Okay, Clinical thermometers are not having this range from 0 to 100. They have very limited range. Okay, like for suppose you want to make your own thermometer, so you will take the same thing, where is okay, and here you will fill the mercury, and you can say, sir, I will take this range 35 to 45. So you will first keep in the 35 degrees Celsius water, and here you can write 35. Then you will put in the 45, mercury will expand. Suppose mercury going up to this, here you will put 45, and this is whole space you can divide into 10 equal parts. Here each division equal to 1 degree Celsius. This way we can make our thermometer. So if I give you all the things to you, mercury is given, tube is given, all the things are given. Can you make the thermometer? If everything is given to you, can we make the thermometers? It's just I told how to manufacture thermometer. Okay, you don't have to manufacture. No one is going to ask that manufacture thermometer, but we should know how it is done. Okay, only thing right now I'm interested that we need 2 points. One is the lower point, one is the upper point. Okay, here, and you can take any point, like here I'm taking 35, 45. Someone can take some other limits. Okay, so we can take one lower point, one upper point is required to take any value for the lower and upper point here. Okay, and here we can use any of the liquid. Okay, solids generally will not use because solids are having lesser expansion, so we use the liquid. Okay, we cannot use any other liquid. We have to use those liquids which are having more expansion, low specific heat. Water cannot be used because water specific heat is more. Okay, yes, can we use the gases? Can we use the gases? Can I use any of the gas here? Yes or no, you have to say. Gas. Okay. Yes, gases will be having more expansion. So gases can be used. Okay. So I will tell thermometer based on the gases also. Okay. Because they have more expansion. But okay, it will be somewhat challenge to make that okay for you, because if I give you mercury, you can easily make tube, mercury, and then okay, ready. For the gases, it will be a little bit challenge, but thermometer exists based on the gases also. Those are known as your gas thermometers, and we'll see those things also. So now, going for the, so if I say, suppose I am making this scale here, so the X, so you can say, sir, you need 2 points. One is the lower point, XL, one is the upper point, that is the XU, okay? And these points are fixed once, okay? Sir, why we require low specific heat? If high specific heat is there, some for the water, specific heat is more, you have seen, okay? So what happens, you have seen this thing, water is used as coolant. Reason is water will be heated very, 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 very slowly and cooled also very, very slowly, okay? Water cannot heat fast, okay? Like this is the water here, and then, okay, I have this, okay, a lighter or flame, water cannot be going to 100 degrees Celsius very fast. Slowly, slowly heated and slowly, slowly fast, okay? But here in this case, we need the, it how to respond to heat faster. Otherwise, it will take more time. If you take the water, if I put here water, now water will take so much time and you will never get the perfect reading. Okay. So now we can say that we need this XL and XU. This is known as your lower, okay, point, but these points are fixed. Once we are making any scale, this becomes fixed. So we can say this one as lower fixed point here, and upper one, same way we can write, okay, lower fixed point. And okay, in short, I can say LFP, and this one you can say this is the upper fixed point, and we can write here this one basically in short UFP. Okay, and you have seen that because sometimes I can use this here 0 degrees Celsius, here 100 degrees Celsius. 0 degrees Celsius is known as freezing point. This one is known as boiling point. So sometimes I can use this language also in questions. Sometimes this language can be used, that ice point, freezing point, okay, boiling point, steam point. So when these are given, you will take lower point as well as upper points are given. If I give you ice point and steam points are given, you will always consider, so this is the lower and upper values are given here. So I can say somewhere in the questions that this one as ice point, okay, or I can say freezing point also, and somewhere I can refer this one as, okay, a steam point, or I can say this one as BP also, boiling point. I have this one scale here. And same way I'm making another scale. This is the y scale, okay? And for the y scale also, this is the yu, this is the yl. Now these two scale I need to calibrate. I need to find some relation between these two scale. So what we can do, one is the method of graph. Of course, that one we are not going to do, because graphs, you always have fear from that one. So directly I will say here, this one what you have to do. Whenever questions are there, everything is based on these things only. Here, whatever I am doing, same thing I have to do here. What I will do here, middle minus lower divided by upper minus lower. Same thing I will do here. Middle minus lower divided by upper minus lower. Okay. You can say x minus xl. Here also xu minus xl. Same thing, y minus yl divided by yu minus yl. Or we can say this minus this divided by this minus this. Same thing here, this minus this divided by this minus this. Okay. So we'll make the relation now. You can say sir, x minus xl. So x minus xl divided by, we can write xu minus xl. Okay, x minus xl divided by xu minus xl. Same thing I will write for this scale also, and then we can write here this one. Here it goes, y minus yl divided by yu minus yl. Okay, I hope it is clear to you. This is not the formula that you need to remember. You don't have to remember any of the formula in this chapter. Just whenever any question is given to you, what you have to do basically, just make the diagram properly, write your lower as well as upper values, and then nothing else. You will write this minus this divided by this minus this. Here also you will do this minus this divided by this minus this. That's it. I hope you can do this thing. This minus this divided by this minus this equal to this minus this divided by this minus this. Yes. What I'm saying, whenever any question, we'll take the question, 3-4 questions we'll take. What I have to do, this one is the lower point, upper point will be given, we'll write. Lower point, upper point will be given, we'll write. Okay. Here what I'm writing, this, okay, minus this. Then here also you write this minus this. Here if I'm writing this minus this, then here also this minus this. Means I can write x minus xl divided by xu minus xl. Same thing here, y minus yl divided by yu minus yl. I can do vice versa also. I can do, sir, I can do this also. This minus this, yes, xu minus xl divided by x minus xl. Here also same thing, yu minus yl divided by y minus yl. That is the same. But I am using this thing that will do x minus xl, okay, divided by xu minus xl. Here also I will write the y minus yl divided by yu minus yl. I hope these things are clear now. Because we don't have to, okay, we don't have to mug up this formula. We have to just make the diagram and then solve the question. Yes. I will take the questions now. Okay. So with the questions, you will feel a little bit okay, confident, and then you can, yes, we can do any type of question on this. Okay. So ready for the question? Okay, then right. So these scales are basically hypothetical scales. Okay. That is the same thing. Okay. We can say UFP. Okay. In terms of UFP also you can write, no problem, okay? In terms of UFP also you can write, but I'm not writing UFP, LFP, what, okay? X minus XL is better, or, okay, this minus this divided by this minus this, this minus this divided by this minus this. In fun way you can remember easily, okay, finished. Okay, so now I can say, these are the hypothetical scales, means we can make the scales, unknown scales, okay? And some are the known scales, commonly used scale, like Kelvin, Fahrenheit, Celsius. These are the very popular type of scale. We'll do question on these scales later on. First, we have to do question on the this hypothetical scale. So, right, in hypothetical scale X, LFP and UFP are minus 10x, 90x, minus 10x, 90x. Means lower value is 10x, upper value is, means lower is minus 10x, upper is 90x. Whenever one line is given, from that line, okay, that line you need to translate into figure. In physics, figure is actually important, okay? Each time you have to draw the figure. Whenever you have any question, make this habit of making the diagrams, okay? Figure, we have to translate language into figure. Now we can say, in a hypothetical scale, low LFP and UFP are this, okay? And in other scale Y, other scale y, other scale y, 35 and 285. Other scale y, 35y and 285y. In other scale y, 35y and 285y. Okay. So 100% we know that okay, 35 is basically your lower ones. It should be your okay, here lesser so lower, and then we can this one is more so upper one. Okay, we heard it in find value of up to this written, up to this clear, because two lines are how I told to you. I told you two lines. These two lines we have translated into figure. Okay, find value of 40x. Find value of 40x in y. Find value of 40x in y. Okay, in y scale we have to find the value. Okay, even though if I don't tell the method you will be able to solve, but first questions, that's why I will tell. Okay, next one you will do. So in y I have to find, I will use the same thing, this minus this divided by this minus this. So we'll write here, sir, 40 minus 10. Okay, you will not put x, like this is the 10 degrees Celsius, 10 Fahrenheit, so x is the your unit here, we can say. This one we write 90 minus 10 equal to, we can write here y minus 35 divided by, we can write here in this one 285 minus 35. Okay, 285 minus 35. Now we can say minus minus is plus. So here we have 50. Here we can say, sir, this one is the 100. Here we will say y minus 35 divided by, you will say how much? 250 here. Now this calculation you have to do. You can say, sir, this one is here I can write. Okay, this one is 2. And if I take y minus 35, when this will become to 250 by 2, and 250 by 2 I know 125, and this will go that side. So this becomes 160y. Okay, so this is the answer. Equivalent value of 40x here, 160y. I hope this question is clear. Yes. Any problem here? Can we do any question based on this pattern? No, in next question I will not give you language. Language will not be given to you. You have to, okay, just yes. Okay, clear? Next question. Okay, now I'll move to the next question. I will not give you language. I will just okay, give the diagram directly. In first step, denominator it should be 90 minus. I'm saying this minus this middle. Okay, mid minus low divided by upper minus low. Here also same, mid minus low by upper minus low. Okay. Amina, I hope clear. I hope you are ready for the next question now. Question is okay here now. So this scale is P, this scale is Q. I can give any name. Okay, this one is here. I have taken suppose 30. This is suppose 280, and here I got suppose okay. This is the 48, and here okay I can take how much? 98. Okay, find value of okay 60Q in P. Value of 60Q in P. Here value is given in the Q, you need to find in the P actually. Okay, 60Q in P. So what will the answer? I need answer very fast. Yes. Let's see who will answer fast. 90. Okay, we got the answer here 90. Some people are saying 90. Okay, 90 only. Now we can see P minus, I will solve this one, P minus 30 divided by, we can write 280 minus 30. So 280 minus 30 is the 250 equal to, I can write Q value is actually 60 Q. So 60 minus 48, okay, that is 12. Directly I'm writing, okay, 60 minus 12 is the directly how to write, okay, 12. And here we get 98 minus 48. Then we how much here? 50. Okay, so you can say, sir, this 0 0 cancelled, this will be 5 here, so P minus 30 we can write here 60, it means P equal to 90. Okay, I hope all got the same answer, correct answer. Yes, any problem here in this question? Anyone, any problem? Okay, so these type of questions we can do anywhere if it, okay, if anywhere these questions appears we can do. Yes. I'm asking, can we do? Some people are saying, no, sir. Can we do? Then only I will move to the next one. If this thing appears, we can do. Okay, okay. Yes. Okay. So moving to the next one, can I move to the next? One homework I can give, then I will move to the next one. Okay. So next slide, I'm giving one, okay, homework here. Same thing, and then we'll, okay, move to the next one. Okay. So listen, this is the just for practice. Okay, this is the scale A, this is the scale B. Here I have taken 20. Here this is the, okay, 170, and here this is the suppose minus 20, and this is the suppose, okay, 280, and they are asking value of suppose 30. You have to find in B. This is the, okay, homework you will try. Okay, whatever the answer is there. Very simple question that you have to do the things. Now you will write after this next heading, commonly used scale, means whatever the scale we are going to use, these were the hypothetical scales. Okay, now we'll write commonly used scales that we'll use in our, okay, physics and daily to daily life. So you can say commonly used scale means in daily to daily life commonly we are going to use. So commonly used scale, and here in this one we are having what is the Kelvin, and the Fahrenheit, and then in the Celsius. Okay, Kelvin, Fahrenheit, and Celsius. Now for these scales we have these lower values as well as upper values. So for the Kelvin, lower value is 273.15. Okay, Kelvin. But for the calculation I will only take 273. I will not consider 0.15. Here I will write 373.15. Okay. For the Fahrenheit, lower value is 32, upper value is 212. And for this one, lower value is 0, upper value is 100. Okay, like these are the values here. Okay, now basically you can say that 0 degrees Celsius is equal to 0 degrees Celsius equal to how much? 32 Fahrenheit. Okay, and equal to what? 273.15 Kelvin. Okay. If anyone is saying now that what are the your okay, freezing point in Fahrenheit, directly you can say from here we can compare 0 degrees Celsius equal to 32 Fahrenheit equal to 273.15. Clear? Same thing we can write boiling point. So boiling point is basically 100 or 212, either 373, and we can express in any of the scale. There is no problem. I hope this thing is clear. If they ask, suppose what are the boiling point in the Fahrenheit, directly we can say no need to convert. Yes. Okay. Now we need to find relation between these scales. So you will say, sir, I will do the same way. Same way we are writing. Okay. Okay, same way. And what we'll write? This minus this divided by upper minus lower. So we'll say here K minus 273. I am writing only 273, but you will read as 273.15 because for the calculation I said we are going to take 273. Okay, 373 and minus 273. How much will be there? You will say 100 equal to, we'll say here F. So we can write here F minus 32 divided by, we can write here in this one 180. Okay, 212 minus 32, 180. Means here 100 divisions will be there. Okay, in this one. Here 180 divisions are there. Okay, 180. This is divided into 180 parts. Okay, and here I can say this one is basically, okay, again we can write C divided by 100. So here how many divisions will be there? 100 minus 0, 100 part. Here we can say 180 part. Here we can say 100 parts are there. Now we can see using 20 I can cancel. So here 5, here 9, here 5. We can write K minus 273 divided by, okay, here we can write 5, okay, divided by 5. Here we can write F minus 32 divided by 9 equal to, we can say, C by 5. And this is the relation that you have to remember always. K minus 273 by 5 equal to F minus 32 by 9 equal to C by 5. Okay, you have to keep this thing. Lower upper also you have to remember, as well as this formula. If I say Kelvin and Celsius both, then 5 will be cancelled. Yes, sir, K minus 273 will be equal to what? See, 5 I can cancel. So K minus 273 equal to C. This one everyone knows also. Sir, this will be C plus 273. Okay. So Kelvin is always equal to C plus 273. You have to keep in your mind, because most of the time in physics we are going to put values in the Kelvin or degree Celsius. In physics, wherever you have to put the values, you will put in the Kelvin or degree Celsius. K, okay. 90% times we are going to use K. So this relation we need to remember, K equal to C plus 273, okay. And here if I say this thing, this Fahrenheit and Celsius, you can say, sir, F minus 32, okay, will be equal to 9C by 5, okay. F minus 32 will be equal to 9C by 5, yes. 9C by 5 if you solve, then you can say, sir, 1.8C. 9 by 5 is 1.8 actually, okay. 9 by 5 is 1.8. So we can say from here F becomes 1.8C plus 32. So this we can directly use for the Fahrenheit and Celsius relation. This one we can use for the Kelvin and Celsius, okay. I hope we can remember F equal to 1.8C plus 32, because in your medical college you are going to use this one. In the MBBS, this formula will be told to you. F equal to 1.8C plus 32. In your geology also, this will be told to you. After this, your geology class, this formula will be, okay. They will say that, yes, we got this, okay. They will treat as the very big formula. We will treat this as nothing, okay. For us, this is nothing, okay. We can directly, okay, get F equal to 1.8C plus 32. Can we do the questions on? Can we do questions on this topic now? Today my voice is a little bit changed actually. Getting yes. One question on this one. Can I say one question here? Okay, based on this, and this is your general knowledge question. Everyone knows. Okay, means I will say the question. You will tell the answer. Okay, so write question first. You can finish out these things. Then first finish these things, then I will ask the question. I need answer very quick because everyone knows this one. Find common temperature. Find common temperature in degree Celsius and Kelvin. Find common temperature in degree Celsius, not degree Celsius and Kelvin. Common temperature in Celsius and Fahrenheit. Celsius and Fahrenheit. Common temperature in Celsius and Fahrenheit. Celsius and Fahrenheit, I'm asking. Common temperature in Celsius and Fahrenheit. That point I will tell next, okay? Whatever I said. Right now, Fahrenheit and Celsius. So you will say, sir, if you have to find the common temperature, means C is X, then Fahrenheit is also X. Both are basically XX. Common means same. Then we can use this relation F equal to 1.8C, okay, plus 32, okay? And then I will put here X equal to 1.8X plus 32. So we can write this one this side. So it will be 0.8X equal to 32. So I can say X equal to 32 divided by 0.8. If I remove the decimal here, then this becomes 320, okay, by 8, and that actually becomes with the minus sign. Minus will be there, okay? Minus. So I can say this becomes here, okay? I can write here only or here, minus 40. But listen, minus 40 is not the answer. Minus 40 is not answer. Answer will be, sir, C equal to X means minus 40 degrees Celsius, or I can say F equal to X equal to minus 40 Fahrenheit. So minus 40, either you say in the degree Celsius, either you say in the Fahrenheit. Both are same, okay? This formula you have to remember always, okay? Means we can say minus 40 degrees Celsius is same as minus 40 Fahrenheit, okay? I hope this thing is clear. So if I ask any other question, here I have given that both are same. Next question I will say reading of Fahrenheit twice of Celsius. Next question I will say reading of Fahrenheit twice of Celsius. Can we do this one also? Reading of Fahrenheit 4 times of Celsius. Can we do that also? Okay. One question I'm asking before that, okay? Can we find a common temperature in the Kelvin Celsius? In Kelvin and Celsius, can we find common temperature? What do you say? Common temperature in the Kelvin and Celsius. If you can find, then tell the value. Okay? If you are able to find, then tell the value. And if not able to find, then say we cannot find. We not possible. Possible or not possible? Not possible, because if I say here in this way, you see, if I put here X and here also X, so what will happen? X will be cancelled. You will never get the things. Actually, this X cannot be X plus something. X cannot be X plus something. So there is no common reading in Celsius and okay, Kelvin. They will ask which of the following pair cannot have same value. They will give the options like this: Kelvin, Kelvin Fahrenheit. They can give you Celsius Fahrenheit, Kelvin Celsius. So which of the following pair cannot have same value? Which cannot have same value? What will be the answer? Which option will take? C and K. So you can write 1 point here. 1 point you can write. C and K cannot have same reading. C and K cannot have common reading or same reading. Okay. In C and K, common reading not possible. Okay. You can written this point. C and K, common reading not possible. Written. Okay. Next question I'm going to give you. Ready now? Okay. Right. So this one you have to remember that C and K, common reading not possible. Right. Question: If reading of Fahrenheit is twice of Celsius, find temperature. Find temperature. Reading of Fahrenheit is twice of Celsius. You will say, sir, Celsius I will take X. It means Fahrenheit is 2X. Okay. Then we have to find. So what we can take here, you will say the relation. Okay. F equal to 1.8 C plus 32. Tell me the answer fast. This is the relation that you have to use. Options I will give. Options are here. 160 Fahrenheit, 80 Fahrenheit, 240 Fahrenheit, and D we are having here 320 Fahrenheit. Out of these 4 options, you need to select any one. A, B, C, D are there. What will be the answer? Solving question is not enough. We need to select our option also wisely. Sometimes what happens, we are able to get the answer. We are not able to solve. We are not able to select options. Okay, I will just tell, just seniors are there. I give one question, and that question answer came this 121 by 81. 121 by 81. This was the answer. All got the correct answer. Okay. Options I gave 100 by 1. B was 10 by 1. C was 1 by 10, and D option was 3 by 2. 121 by 81. They got, everyone got 121 by 81 this answer. Everyone got. But a lot of people didn't put the answer by thinking no option matching here. A lot of people didn't put this answer by thinking no option matching. Yes. So you will also leave this question. I give option like this. Will you also leave this question by thinking we cannot leave? We need to, okay? In physics, approximation is valid. I told to you just recently, okay? The Sunday exam was there. In Sunday exam, I give this question. You can say, sir, 121 is nothing. 120, 81 is nothing. 80, 0 cancel using, okay? 4, we can say 3 by 2, and 3 by 2 is the answer. Simple, okay? So selection of answer is also important. So now we can say C is X, F is 2X. So I'll put here 2X equal to 1.8X plus 32. I can take this side, so 0.2X equal to, okay? We can write here in this one, how much here? 32. So X equal to, I will get 32 divided by 0.2. I will remove the decimal, so this will be how much? 320 by 2, that becomes 160, okay? 160. Now our answer is not 160. We'll say F equal to 2X, so that will be the 320 Fahrenheit, and C equal to, I will write X, which is the 160 degree Celsius. So as per the options, this answer is correct. Yes, done. Done. Can I give you one homework? Because now time is up for the class. Can I give you one question for homework? Will you do? Okay, very good. So now question is reading of, question is this, okay, ratio of reading of C and F is 2 raised to 3. This is the, okay, 2 raised to 3. Ratio is given 2 raised to 3. What you will take? You will take CH 2X and you will take FH 3X. Then you will solve the question, okay? Can we do this thing? Yes. Okay, so bye. Okay, practice these things. Okay, just whatever the questions we have done, okay, practice properly. We'll meet in the next class. We'll continue this thing. We will finish, then we'll start our new chapter. Anyone having any doubt here? Ask fast. If any problem anywhere, whatever we have discussed, any. All clear. Bye. Yes, bye.